So for pre-calculus, understanding vectors is important. Again, vectors do tie with physics as well. But this lesson is just giving you an overview of vectors, their magnitudes, their directions. So just to define a vector, right? So a vector is a quantity with an arrowhead, right, which has a direction and a magnitude. And so really, again, you want to make sure that it has a direction and a magnitude. For instance, velocity, right? It has a particular direction as well as a magnitude. And obviously there may be positive and negative components, right, that are associated with vectors. So if you, the first thing I want to really go over is adding vectors. So if you want to add vectors, right, you may be given, right, for instance, it may say that given u is this, right, or is 3 comma negative 2, right, and then you may be we here is given as negative 4 and then 6. So that's how you can denote the vector as, right, using this symbol here. So 3 comma negative 2 and then negative 4 comma 6. And again, those are the components. This is your horizontal component, this is your vertical component. So the components is the terminology for these measurements here, negative 4 and 6. 4 in the direction that's left, 6 that is in the direction that's right. So that's how you would you really denote vectors as. Now when you're adding vectors, right, so say you want to determine what's u plus v here, right? So what you do is you really just add the horizontal components to determine your overall horizontal components. So you're really just doing 3 and adding that to negative 4, right? That's just negative 1. So here, when you are really denoting u plus v, you're gonna say that that's negative 1, and then you would do negative 2 plus 6. That is 4. So that's u plus v, right? That is how you would write u plus v as. Now if you have u minus v, for instance, right, that's subtracting vectors. Again, it's the same concept. You do 3 minus negative 4, you get 7. That's subtracting the horizontal components, and then you would do the same for the vertical components, right? That will give you negative 8 here. So 7 and then comma negative 8. So that will be your final answer here, if you were adding or if you were subtracting. So that's pretty easy. You're just subtracting, adding those components there, and now comes the magnitude. So if you're given this, you're given that 2 comma 3, right? That this is the way how you denote the vector. So if you say that this is I don't know, this is vector A or something. This is vector A, and you want to find the magnitude of this vector here. The symbol or the notation for magnitude is that, right? That's how you show that this is the magnitude of vector A. And again, like, this was more of you defining that, okay, this is the vector, the specific vector that has 2 units as the horizontal component, right, and 3 units as positive being the vertical component. This is saying the magnitude in the sense the length, right, the length of the vector. And so when we talk about the length, we're really just talking about the Pythagorean theorem. So if we have something like this, the best way to determine the magnitude is to use the Pythagorean theorem. So really, this is equal to 2 squared plus 3 squared and the square root of that. So that would be square root of 4 plus 9, the square root of 13. So this is equal to the square root of 13. And the reason why is, you take any vector here, and when we say that the horizontal component's 2, right, so this is 2, the vertical component's 3, right, so we know our vector, that's how our vector is. So obviously the vector, if it's going like that, its magnitude, right, its magnitude must be the length of the hypotenuse, and we can determine that by using the Pythagorean theorem, again being 2 squared plus 3 squared and its square root. So square root of 13 is the magnitude of this vector here. Now comes the direction. And so for direction, I think the easiest way here would just be to use the trigonometric function of tangent. So if we say that we already know the tangent of theta, right? Tangent of theta is equal to y over x. Again, that's just the basic, right? It's the opposite over the adjacent side. So if we say that a specific angle, right? If we say that a specific angle here is theta, right? We do not know what it is, and so obviously this is our vertical component, this is our horizontal component, right? This being y, this being x, or opposite divided by the adjacent side. That's how we define tangent theta as. So we know that tangent theta is equal to y over x, and in this case we know that tangent theta must be 3 over 2, right? Because we know that the vertical component is 3, right? And the horizontal component's 2. Therefore, tangent of theta must equal 3 over 2, or 1.5. Now, to determine exactly the degree, right, because we're finding the direction of this vector here, specifically vector A, we would do tangent inverse of 3 over 2, which is 1.5. Right, again, tangent inverse, because that's the ratio. We want to see a specific angle for which tangent of that angle satisfies and gives us 1.5. And so doing this inverse of 1.5, tangent inverse of 1.5, we get 56.3 degrees. So we know that this angle over here, the direction must be 56.3 degrees from our x-axis, from our positive x-axis, right? So it's 56.3 degrees from the positive x-axis. So that's how you would find the magnitude and the direction as shown here using tangent of theta. Now there's another notation that you want to know, right? So as it said, your magnitude can be denoted by this, right? Something like that. The other way to show the magnitude, first you have something like this, right? You want to know how you can represent vector A as. The other way would be, so you say v is equal to, or not even, in this case it would just be A, right? Because we have said the vectors A. So A, in this case, or let me just change A here. Let me just say this is vector Z, for instance, right? So let's just make it vector Z here. Right, so we say that Z is equal to AI plus BJ. That's the other way of showing the notation. You may see it as this, or you may see it as that. And obviously here, we may see something like, I don't know. So in this case, this would be Z is equal to 2I plus 3J. The J is really associated with the vertical component, and the I is associated with the horizontal component. So you have Z is equal to 2I plus 3J. And that's how you would show that as, right? Or you may have something like, I don't know, you may have something like 5, comma 6, right? As another vector, right? And so you will denote that as 5I plus 6j. Again, the I and j are just variables. They're showing that it's the horizontal and the vertical component that you're talking about, right? So that's how you may write that as. Now that's just labeling the vector, right? How do we exactly determine the magnitude? And it's the same idea. You know that 5 and 6, right? 5 and 6 are here. Well, here we knew that it was, so we knew that this was 2 and 3. We already know that 2 is the horizontal, 3 is the vertical. And so we use the Pythagorean theorem because it makes sense. Similarly, when we're given a notation like this, we just have to understand, oh, 5 is before I, therefore it is the horizontal, 6 is before j, therefore it is the vertical. And so we still know that when we're finding the magnitude, so we're finding the magnitude of vector z here, that is still equal to the square root of 5 squared plus 6 squared. So that's 25 plus 36. The square root of 25 plus 36 is the magnitude of vector z, which is really the square root of 61 units. So the square root of 61 units is the magnitude of vector z. And similarly, you can denote this as 2i plus 3j, and you would again do the same thing looking at the coefficients. You would do 2 squared plus 3 squared, and the square root of that. And that would give you the magnitude of this vector over here. So that's just another way of showing this as, right? And so this is basically the main concept of vectors, right? More like directions and magnitudes. In the next lesson, I will be going over unit vectors, a more specific type of vectors. So for this lesson, thanks for watching.